Okay, I guess I'm just recording the iPad, so it doesn't matter too much. But the point I'm trying to get at is this is how I do it. It's not perfect, but it works pretty good for me. Um, and so let's kind of talk about the goal of this talk. Is I'm not going to give you my documentation and my commands because they're always changing and it's not helpful. But what I do want to impart is a mental model, right? How do you go about thinking about using AI to write software? And the other takeaway, if you get nothing else out of this talk, is that context is king. You have to manage your context and you have to do it effectively. Otherwise, you're going to have a bad time. So if we look at the problem space, if I can not use an eraser, you look at the problem space, it's broken down into two things, right? And I guess let me back up and say one thing is that my goal of this is that I wanted to vibe code. But if you ever tried like honest to God vibe coding where you just like put in some prompts and let it run, the software it puts out is garbage. And I have a very high quality standard for any code that I produce. And if I'm going to sign my name on a Git commit, it better be really good code. And so this is my journey and what I'm using now to produce high quality code that I would put in front of clients. I would put it in enterprise. I would let Zach scrutinize it for software security issues, right? The whole nine yards. And so if you're looking at the problem space of software, it is divided into two things, right? You have the planning and the execution. And I'm going to spend a little bit of time on planning just to make sure that we're all on the same page. If you haven't lived in the world of Agile, that's what I'm using. All of these models and the way I model software comes after how I have professionally developed software. And so I'm using my own experience as a model to write instruction sets. So with planning, it starts with requirements, right? Your friend comes to you with an app. Your friend comes to you and says, "Hey, I want to build an app." And you're like, "Cool. What does that mean? Who's it for? What's the problem space? What kind of things are we solving? What does it look like?" And you have a whole bunch of questions, right? This back and forth dialogue is gathering requirements. Okay, you start there. Step two is an epic breakdown, right? So an epic breakdown is taking your set of requirements and chunking it into high level sections of work so that you know we're going to do this epic and then we're going to do this one and we're going to do this one. It's about breaking it down into tasks, right? And that's all Agile really does for you with some more things. But the third level of epics get broken down into features, and that's usually feature refinement. And if you can't read my handwriting, I'm sorry, but I'm talking. Also, I am not an English major. I'm an engineer. So if I spell stuff wrong, tough. Uh, and then from features, features are composed of tasks. In the ideal world, the sum of the tasks are representative of the entire requirement set that you and whatever other entity you're working with uh, comes up with. And this is how like we break down planning. But when you do it with AI, how do you do it from there? So I organize my sets of commands into numbered commands, right? Literally, because when you bring on when you look at somebody else's like workflow structure, it's always like just words, and I don't know what order words come in. So I use numbers because one comes out, then two, and then three, and then four, and it makes all the brain power go to planning stuff rather than trying to figure out what code comes next. So literally, my /1 command is requirements. My /2 command is epic breakdown. My /3 command is actually both of these tied together. But the point is that when you use this kind of breakdown for uh, requirements, epics, that's not features and tasks, what you want to make sure is that you have high cohesion between your requirements, between your requirements, between your epics, between your features, between your tasks. You don't really want gaps between the two, right? Because this leads to bugs. You want to make sure that your epics are tied to your requirements, your features are tied to your epics, and your tasks are tied to your features. And the closer you can get this together, the tighter plan you're going to have, and the better time executing you're going to have on the other end. If you've ever been in the professional world and you're sitting through feature refinement and you miss a feature, it comes back up down the road in code review or in QA when they're like, hey, shouldn't we be doing this? And you're like, we never talked about that. And then you ship broken code and everybody's unhappy. So what I'm getting at is that going through these steps multiple times, right? You tell the AI, hey, let's take the requirements and break it down into epics. Great, you did it. Let's do it again. Great, let's do it again. And so when I do this, I usually do the epic breakdown 3 times, the feature refinement 3 times, and the task refinement. Well, they're together, so they're kind of a joined 3. But I go through it multiple times, and what that iteration does is it captures more and more of these requirements, making sure that they're in alignment, things work, and that we actually have a plan. My buddy Eisenhower, who I would be cool if I actually got to meet him, but he said proper planning prevents poor performance, right? And being able to define your problem is half of the battle of being able to solve it. And that's kind of where all that stands. Looking at the execution side, actually, and I'll mention one more thing before I continue, is that the way I organize my my commands, because it's come up a little bit, right? So we have this 1 through 3 idea. 1 through 3 is for people. Like I, as a human, execute this. I also have a /util, right, for utilities, but I've got a bunch of /sub commands, which are for when commands call other commands, because we want to chain them together. And I'll get more into that later. And then I've recently added an _eval because I realized that I need to actually figure out if I'm regressing or not, which is it's a whole other can of worms, but it's there and it functions. Okay, looking at the execution space. How do I write code? If I'm going to manually write code, what am I doing? And the answer is test-driven development. If you don't know what test-driven development is and you work in the professional space, let me give you a brief education. It's the idea where you write test code, right? You write a test case that fails, and then you write application code to make the test pass green. And then you go back and you write more test code so it's red and fails, and you write more application code so it's green, and you go in this cycle. It's a very fast loop. The whole point of it is that you only write the application code necessary to pass the tests. This way, you're not spending half a day writing out application code that doesn't matter and isn't tested. Because if you don't have tests for your code, you can't trust it. So that's great and all, but if you've ever spent time in the testing space writing tests, you can easily fall into this trap of testing implementation details, which do not matter. The user doesn't care about what fetching library you're using to make HTTP calls. And you shouldn't care either, at least your test shouldn't. And so what I do to distinguish is I add behavioral test driven development. So all of your tests are one-to-one requirements with the user requirements in your tasks. If you've defined your tasks appropriately, at least the acceptance criteria, it is all business related. All the way down this stack is business. It's not technical. And because this describes the what, the code describes the how. And so if you're going to use your tasks to define your behaviors, then you're able to write test cases that very closely adhere to the software code that you're writing. My general framework, and I'll not spend time on this, but is for organizing tests is given, when, then, right? So given something is happening, when a user or a role does something, then I expect thing to happen. If you're familiar with tests, these two are describe blocks. And this is, it's it in a lot of JavaScript or test, right? But then you need to also closely adhere, like having good test descriptions is fine, but you also have to have good quality tests in and of itself. And this is what the arrangement in the testing world is: arrange, act, assert. So you organize your test cases like this, and you organize your test code like this. And between the two of them, you get very good parity from your test cases to your application code to your user requirements. Again, my goal is to be able to plan out stuff and let AI just run with it. I don't want to have to spend time debugging code. I don't want to have to spend time reviewing its code. I want to be able to trust it. right? If you've ever been in the management space, managers don't go in and look at code usually. They delegate it out to their team leads, and they just trust that it happens. My same goal is that. Now, without getting into mocking and network boundaries and stuff, this is a good place to kind of cut over to the actual execution path of the workflow, right? So a guy named Dexter Horthy back in November came out with this idea of research, plan, implement. And it was this idea where when you're going to implement application code, you first want to let the AI research what it's about to do, plan out the tasks it's going to have to go through, and like technical tasks. We're in the technical space now, and then implement from the research and the plan to get your code going. This is effective, and I adopted it quickly after he talked about it. Looking through some other well known and popular like workflows like superpowers, I think, and a few others, I added deslopify. That's a D. Deslopify, which is basically like, are we following good practices, right? Because AI, again, the reason we go through the planning multiple times, AI doesn't necessarily get it always in the first go. So you give it a couple rounds, and this chain allows it to effectively produce working code. Now, recently, in a video, maybe 2-3 weeks ago, Dexter got back on stage and said, "Okay, that's wrong. We're going to do it differently." And he gave a different acronym, and that's cool. But the only thing that I wanted to add from it was a structure step. So it goes research, structure, plan, implement, deslopify. And the research is about gathering implementation context for the task. The structure now, the structure defines the solution space. Plan maps acceptance criteria to a test first implementation sequence. Implement actually does the TDD itself, or behavioral TDD, if you will. And the deslopify ensures that your best practices are followed. So what I had originally was this idea of, okay, my fourth command was just going to be a task. Cool. So I would run my command, I'd run my task command, it would go do a task, it would work for 2 minutes, and then I would need to give it another 30 seconds of attention. 2 minutes on, 30 seconds, or 30 seconds on, 2 minutes off, 30 seconds on, 2 minutes off, 30 seconds on, 2 minutes off. It felt like forced EDD. And after a couple weeks of this, I thought I was going to go insane. And so I said, okay, why don't we take this idea and expand it out, right? If a task has these steps, right? Research, structure, plan, implement, deslopify. Then we have features. Whoa. We have features that are going to come in and do these tasks one at a time, right? And just chain them together. Then at the end of the feature, we might add a few new things like a verification, a strategy check, and then a fix if necessary. So this is a little better. We went from running from, I don't know, maybe 2 to 5 minutes to running for 45 minutes to an hour. And that works pretty well. And based on, Claude, I use Claude Code. And I forgot to mention that. Claude Code is all I use. But this usually, I can get through most of a context window in this time, 50 to 70%, depending on the complexity of the task. But I decided to take it one step farther. And I said, okay, why don't we add an epic, right? I actually want to do this from an epic perspective. So we're going to take a bunch of features. We're going to chain the features together, right? And then eventually we're going to add a couple things at the end of the epic so that we're, making sure that we're spot checking it, we're smoke testing it, we're making sure that things are running and building, passing CI, et cetera, et cetera. And so what comes out of the other end is a feature verification. So another verification, another strategy check. Actually, that's a security check. Excuse me, security check. And then documentation. Because who doesn't love documentation? It's one of those things that like people hate writing documentation because it's one of those things that as soon as you write it and commit it, it starts to atrophy. It starts to die off. But if you just hook it into your AI process, you can have always up-to-date documentation. And it's not just things like run books. but it's also ADRs or architectural decision records. So it says, why did we choose this way of doing something? And those are helpful for when you go back in the past and be like, why are we using this library again? Or what's with this weird hacking workaround? You have documentation to at least tell you why. It's also nice because when you have you can tell your AI to go look at your Git history, look at your documentation, and create a story for how has your code evolved over time, which is kind of fun. Um, Getting back to what Dexter was talking about earlier, he mentioned something that I thought was very enlightening. Did I just change that to like rainbow? No. Um, is there's this idea of the context, right? You have a context window, and the first little bit of your context window is tools. Tools. The last bit of your context window is compaction, if you keep it on. And then you have all this space in the middle to work with. But if you use all your context, you start to realize that you get degraded performance over time. So around the halfway point is what we call the dumbs. Well, that's a D. Why did I get it's a square now? Hmm. No, this isn't AI. This is just good old Microsoft. Um, Dumb zone. No, it did again. Anyway, ohm zone. But the idea is that your performance drops off. So really what you have in terms of context to work with is this space here. Okay, so if you have 1,000,000 tokens, 500 tokens is this part. You're using 15% here. That leaves you with about 350K tokens to work with. Or before that, it was a 35,000 tokens, what have you. Okay, so if you're gonna go through and do these loops, right? If each feature, okay, each epic, we'll do some ballpark math. Each epic has, I don't know, we'll say 5 to 8 features. Each feature has 5 to 8 tasks. And each task has, I don't know, 6 steps. Math 25 times 6, 125. Did I do that right? 150? Something like that. Anyway, it's a bunch of loops that you end up doing. And so if you just tell one agent to go through all of these loops, you're welcome to come in, by the way. If you tell one agent to do these loops, you're going to fill up this context really quickly, right? And then people realize this and they said, okay, now we're going to use multiple agents to do things. So we're going to take our agent and we're going to say, okay, we have agent. I'm going to give him a little smiley face. With some antennas. Right, so you have your instruction set, and you say, okay, I want you to spin off a subagent to do a task. The subagent is going to do the task, and it's going to return a result. Wow, you were killing me today. You were just doing this earlier. Okay, right, and then the second subagent takes that output, does another thing, gives it back. There's an arrow there. And you go on and so forth, right? So this is good. This is progress. We are now saving context in our orchestrator agent and delegating it out to subtasks or subagents or agents, however you want to do it. Right? So instead of using all these contexts in the main agent, we're now able to just take the answers. Wow, really? Oh, this button, I found it. Aha. So now we just have answers coming back to the main agent or to the orchestrator. And this is good because we save, I don't know, what is this, like probably 10 times space on each individual task. But over really long cycles, if you're going to let Claude run for 2, 3, 4 hours at a time, it's going to start to drift. You're going to run out of room in your context, even at 1,000,000 tokens or 350,000 tokens, as we saw before. So how do we pare it down even more? Well, the short answer is that you give subagents, right, these buddies, the ability to write to disk. Instead of returning their context to your orchestrator agent, just for your orchestrator agent to pass it to the next subagent, just return a file path, right? So you go from context to single line, single line, single line, right? This is good. This is a significant improvement because the next subagent can just read the spec that was previously put out and act upon it, making progress. But the issue comes, we're not done with this problem, right? And this is something that really got me not in my head, but like trying to understand a way around it. And I came up with this cool thing, which I have dubbed a caterpillar pattern, which we're going to talk about, which is the idea. This is my caterpillar, if you guys didn't know. You give it an instruction, and usually what happens, I guess pre-caterpillar, is you have your instructions up here, and your instructions might have, I don't know, 3, 4 phases. We'll call it 5 for nice round numbers. And then you do a bunch of stuff that fills up context. And you're filling up context, filling up context, filling up context. You're starting to get dumb. And then you're like, okay, I need to wrap up this task. So by the time you're here in this space, you have so much what I'll call context pollution from your orchestrator agent that it may or may not follow this instruction correctly. And if I'm going to write out instructions for agents to follow, I want them to follow them to a T. That's really annoying when they don't. They start hallucinating. You find out down the road, either from your users, hopefully from your tests, that you're drifting. So my solution was this. We take our agent and we give him, the tools in the first instruction. So this would be my fast/5, which is my epic implementation command. You get tools and instruction number 1. And it's going to execute on the instruction number 1. And at the end of instruction number 1, the command that follows is go implement another set of instructions. So we're going to do 5A. And so it's going to load the next command via the skill tool. And skill tool and skills are not the same thing. I want to make that clear, right? So real quick, in case you're unfamiliar, skill is a tool. You have tasks, which may be depreciated, and agents. This runs inline, in line, and these spawn processes, or sub-processes. Sub with a B. Right. So if we use the skill tool, it's going to take the next piece of command, load it in the bottom of the context, or the freshest part in this case, and execute on it. Okay, so then it's going to do another chunk of work. Getting a little messy here, but that's okay. And then when it's done with that, it's going to automatically load 5B. It's going to load this stuff. Link, right, directly call it. And so if you repeat this over and over again, even when you get into the dumb zone, because the command is loaded so fresh in the context, it will follow it almost to a T. And so when I let Claude run for 2, 3, 4 hours, I've had significant improvement over its ability to follow instructions, right? Which is this whole set of planning that we did way earlier. If I can, nope, we're not going over there apparently. But all the plans, you want it to follow them. And this is really what allows that. So this has been phenomenal, and I highly recommend you figure out how to increase your ability to manipulate context in your favor. And the cool thing is that if you compact in the middle, right? Say you run out, and you can compact at the end of each task, and because the box of instructions is so small in what you do, it's going to remember the last command, it's going to link to the next one, and you can compact after each feature, right? So you start with basically a clean slate, the command you just loaded to do the next step, and it continues. And so when I run my epic command, it goes 5A, which is like some prep work. 5B actually like runs through the feature, is a feature loop. But when it's done with 5B, it's going to call 5B again. That was backwards. But it's going to call 5B again because it can call itself in a loop. And it can do the next feature. It'll call 5B, do the next feature, call 5B, do the next feature. And we end up working with commands in Claude like we do programming. We have branches, we have loops, we have assignment. These things are fundamental to building software systems. And just because we're not writing code, we're using natural language, doesn't mean they don't still apply. So if you can follow software fundamentals, even when you're building systems, you're going to have a lot of bang for your buck. I'll give a couple other things that are superpowers, I guess, when it comes to working with AI and workflows, and I'll wrap up. But we talked about logging. Containerization is another big one. I want to be able to have ephemeral environments. I want to be able to spin stuff up, spin stuff down, send it to my friend, have them spin it up, spin it down, run stuff, break stuff, see if it works, spin it down. Highly portable. You want to run it on containers, you want to put it in the cloud, you want to run it on your computer, you want to put it on a Linux box at your friend's house. It doesn't matter. So containerize things. And the other one is logging. Logging is not something that I appreciated for a while, and I've spoken on it at Code and Coffee before, so I won't bore you. But if you go to, is it CNCF, the Cloud Native, is that right? Right. So CNCF, Cloud Native Computing Foundation, has documentation on how to do logging. So literally, I had Claude go read it, put together a skill, and now we log great. But the idea is that when you have logs throughout your application code, and it spits it out into your container, you can just say, hey, Claude, go look at the Docker logs and let's figure out what's wrong. Because it has direct correlations between where we are in the code to where we are in the logs. And it's like, oh, we're missing this log. We must have stopped here. And you can have it put it in automatically. So logging, documentation, containerization, these types of things that help build functional software is no different if you're handwriting it or building with AI. Uh, this process that I have, it works for me. I'm not going to call it a silver bullet. It gets about 95% there, and I still have to go through and test it and click around. I get to put on like a product hat and see what's broken, and then tell Claude to fix it. But if you can say, "Hey, fix it by leveraging Playwright MCP," go click through DOMs with accessibility, hopefully. You can output logs. You can go read the logs, and it can do its own self-healing loops to go fix things, which is a superpower in and of itself. So where I want to go from here, and in terms of like building it out for myself, is I want to lean more into hooks. Hooks run deterministically, and because of that, you can guarantee that they're going to work, they're going to fire, and they're not susceptible to AI stuff. But this is the effective way that I have come to use AI in my workflow. And I hope that this helps give you a mental model for not only breaking down requirements if you don't have practice in that, but also building out tests to make sure that your software has high cohesion to your test suite, has high cohesion to your business requirements, but then also going through the actual implementation workflow of building out with agents, sub-agents, and delegating things out to manage your context. Thank you. Oh, I guess, are there questions? As in pricing. I'm on $100 a month plan. I subscribe to Cloud. I'm not paying for tokens. So, okay, but quick note, if you're a student, $100 a month is a lot of money. However, if you're a professional, right, if you pay a software engineer 70 to 80 to 100K, and I can spend $1,000 a year to even give them, I haven't done math, but like, I think it breaks even to like a 4 or 5% productivity boost. But realistically, I mean, I'm 5x, 20x myself at this. And so, I mean, the dollar amount that I pay for Claude, they're still not making money on it, by the way. So we will get Netflixed over time. But it's well worth it if you're in the professional area.
Have you seen Gary Tam's G Stack? Because as you were going through this, the Y Combinator guy put together a version of what you're talking about here, sort of like a build out skills, deterministic workflows, and all that. Might be worth checking out if you haven't seen it yet.
I have not. Thank you. I will comment that the Ralph Wiggum loop was very popular, and the looping is cool. The Ralph Wiggum part less so. And this is tangential, so
Yeah.
but the idea was I never did Ralph Wiggum because I could not guarantee quality of the outcome. And so by building my own loop with high fidelity plans and looping over things to test and strategy checks and verification and documentation and security checks and the whole 9 yards, you can control your own quality output. Other questions?
Do you write these instructions in the Claude MD file or do you just make separate skills and stuff?
No, my Claude MD file is like 10 lines if I've got one. I usually just run the init and let it run its own thing. But no, these are a set of work. I keep them in my home directory so they're applicable across all commands. But no, I've written out a bunch of markdown files. I think there's 20 to 30 of them. Alpha.
Way in the beginning of this, the requirement phase.
Yeah.
How do you prioritize to get it all to follow? Your epic breakdown into user stories and acceptance criteria. Where is the Moscow method to tell me must have, should, could, and won't have? Where do we put this? Because that's usually done in conjunction with the client, trying to figure out what the hell they really want.
Yes. So That's a great question, and I didn't even talk about. I had an agentic team, right? So I sat and I said, okay, if I'm working on a professional engineering team, who are the roles that I have in play with me? I got front end, I got back end, I got QA, I got security, I got documentation, I have a product, and I have a team lead. The team lead's job, to answer your question, the team lead's job exists to keep it simple, student, or KISS, if you will. There's AI loves to overcomplicate, it loves to over engineer. And if you don't know what you're doing, if you don't have professional or like experience to back up and be able to call AI on the BS that it tries to run past you, you're in for a bad time. But during the refinement to Epic, I have the product and the team lead push back on requirements, and so they will push back. It's like, do we really need this? Are we going for an MVP? Are we trying to roll out like enterprise production code from day one? And if you're trying to do that, it's a huge lift. And the answer is MVP first and iterate, 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 and you'll get better outcomes.
For your task breakdown when you're going to 15A, 15B, do you understand like where's the point of no return when you chunk it to a certain size? You know what I'm saying? To handle more of the drift versus letting somewhat of the drift happen. So you can get more chunk of that. You know what I mean? Like
So that I think that actually comes down to the planning side, right? Because each element in the loop at a fundamental level is a task. And the tasks are small, individual, committable units of work. It's an atomic piece of work. And so Claude Code with a million token context window can do that all day long, no problem. And so it depends on your model. If you're running small local models on your own machine, you might have to tweak it and say you're going to do this one user requirement and then loop to the next single user requirement. I do it in tasks, but it's just because that's what I found worked for me. I'd say it's experimental.
and is your code for this open source or is this just something?
No, it is not open source. For people who work with me, I give it to them, so we can share the workflow on like a team setting. But no, I don't. I don't open source it. That's why I'm here showing you the mental model. This is how it works. And what I have may not work for other people. But what I do is I look at the open source versions of superpowers or oh my Claude or whatever the other ones are and say, hey Claude, why don't you diff what they're doing well versus my set of docs and see what should I pull in to make mine more effective, right? So it's about iterating and looping and testing and evaluating and versioning and kind of all that stuff.
I have one question.
Yeah.
So the entire workflow that you shared, was it your creation or is it more from the side of your knowledge versus online communities and what other people?
I mean, it certainly started as a creation, but as I just mentioned, I use online communities to ideate on what am I missing, right? If you've ever worked in a silo as a single engineer on a project, it's tough. You have somebody else come in and they challenge you, they help you grow, they see things from other perspectives, and it's no different in this case. So like it's homegrown. I wrote the first version of it, and then I had Claude go in and write it itself. You can copy the Claude docs, paste it in its context, and like, hey, we're working on the documentation or like the workflow process. Help me figure out what I'm missing. Because things are updating on literally a weekly basis. And so if you don't keep up regularly, you use old tools or depreciate things.
And when you said you have different roles like front end and team lead, are those different agents that you have listed in your?
No, actually, they're not. And I don't have a good answer for what they are really. They're what I call persona documents, right? So I use a general agent from Claude, like the general agent, and I say you are going to assume this role. Here's your persona. I want you to look at the world through these things. You're going to be you care about these things, you don't care about these things, and you should be mindful of X, Y, and Z. So is it an agent? Kind of, but it's not like in the agent's files. No.
Can you use this process for a benefit analysis, for example? And what's the actual programming going to cost, and what are my benefits for? Uh, Again, we're applying back to the epic breakdown for the user stories and acceptance criteria. Because usually that's the toughest part. Somebody told me, and I don't know if it's actually true, that the estimation to get your project approved is actually more difficult than the actual program.
Absolutely. I don't know. It's interesting because like when you look at traditional human teams will take things and assign points. Points are not measurements of time, they're measurements of effort, right? In the beginning of a project, when you are talking about requirements, you usually do things in t-shirt sizes, so you get a ballpark, right? So it's like, okay, a team of 5 engineers is going to take them 6 months to roll this stuff out. But the thing is, now things that would take me a week to do on my own literally take me an hour. And so when you have that much compression, what do you do with it?
My question. No, that was my goal.
Oh, I don't know. I don't have good answers.
Okay.
Lots of questions. All right, I'll do one more. All right, Azim, what's up?
I say your own. What MCVs do you use like for web development to help automate this?
I try to keep my NCPs minimal because they are loaded in the front of the context window. I do use Playwright. I've got a couple others that are hit or miss if they're okay. Playwright's my favorite because it gives you the front end capability. But grep AI is written in Go and is a knowledge store, like locally running model that allows your main agent, like Claude, to query in natural language grep AI to understand where are things. So instead of using blob and grep and searching tools from the command line to read hundreds of files at a time, it just asks and gets, here's 10 answers. Go dig from there. I've got another one called Serena. I don't know if it works. Oh, Context 7. That's the big one. So Context 7 is just current AI. It's not AI, it's current documentation for whatever libraries you use. So my big ones are Playwright and Context 7. The others, situational. Like I've got some projects use Supabase because I'm using Supabase on some personal projects, but those are my two big ones. All right, ladies and gentlemen, I'm gonna stop talking to everybody. But if you have more questions, feel free to come talk to me. I want to make sure there's a little bit more social time today. You don't have to leave at 3. This is a public space, but I am gonna start closing down at 3. With that, thank you very much. Keep it on.